Okay, geometry, we are in 10-4, and we are talking about perimeter and area in the coordinate plane. So pause, come back and check your work on this little warm-up. And the slope of AB, 3/2. CD, 1/6. And simplifying this, we have 42, 14 times 3. Very good. So today we're going to find the perimeters and areas of figures in the coordinate plane. Remember in 9-3, we estimated the area of irregular shapes by drawing composite figures that approximate the irregular shapes and using area formulas. Well, actually, that was 10-3. That's funny. Got the wrong number there for the chapter. Anyway, another method of estimating area is to use a grid and count the squares on the grid. So we saw this on the quiz. You might have used it to estimate the area of the figures on the quiz. So we can estimate the area of the irregular shape by imagining the smaller shapes that could fill these areas. And so when they look at this, they're finding various areas. They're approximating an area of 4, an area of 3, and so on. And so to find the total area of the composite figure, you basically find the sum, right? And when you add those up, it's approximately 30 units. Now, a second way to look at it is to actually fill with squares. I like this method. This is an easy-to-use method. You approximate the little pieces as halves where you can. Notice in some places you don't even add them in, right? In other places, the half is actually a little greater than that piece. So you kind of just do some estimates, count your squares, and in this case we have approximately 31 units. So 2 methods for finding the area of irregular figures. Today we're going to find the perimeter and area in a coordinate plane, so we may be using our distance formula and also our slope, which I know you are all very good at. So finding the perimeter of a figure, first of all, if you're given the figure with the coordinates, the first thing you'll want to do is draw. So they drew the figure and classify it. So when you classify it, can we say that this is a parallelogram just by looking at it? We'll probably want to check out the slopes, which you may have already done, right? And so we see a slope here of -1/3 and a slope here of -1/3. And in this case, we see +2/3 and +2/3. So it does look like a parallelogram, doesn't it? So that's exactly what they're doing for you here. And they found a parallelogram just the way I did. It's easy to do with a drawn figure. You could also do this using the coordinates, just a little trickier imagining it. Okay, since it is a parallelogram, we can find out if it's a particular type of parallelogram, right? For instance, if all sides were equal, we might call it a rhombus, right? And so on. So let's see what they do here. They're finding that EF is square root of 10 and FG is square root of 13. Oh, they're finding the perimeter. So they simply double each of those lengths, add them together, and the perimeter is 2 square root of 10 plus 2 times the square root of 13. And in finding the area of EFGH, we notice that they have drawn a line to divide this into 2 triangles. So if we look at that, we can draw a dividing line here, right? And we could call that the base of both of these triangles. And the height would be the perpendicular distance to the opposite vertex. So this one would be 3 by 3, so half of 3 by 3. And this one would be 3 by 3, or half of 3 by 3. Again, so we have 2 times 4.5, or we have 9 units. A second method for finding areas in the coordinate plane would be to use subtraction. And so to find the area of this polygon with vertices A at -4, 1, B at 2, 4, C at 4, 1, and D at negative 2, negative 2, we see that a larger rectangle has been placed surrounding it now. So what you could do is find the area of the rectangle, right, and take away the individual triangles. They're all right triangles. So that would be a straightforward way to find the area. Draw the polygon and close it in a rectangle. The area of this rectangle is 4 and 4, 8 times 6, or 48 units squared, right? Now what they're going to do is show you that you can use the base and height, all of these legs that are right angles, to find the areas of these triangles and subtract. So the first triangle, A, we could say has a base of 3 and a height of 6. Half of 6 times 3. B has a base of 2 and a height of 3. So half of 2 times 3. C has a base of 1, 2, 6 and a height of 3. So half of 18. And finally D has a base of 2 and a height of 3 again. So we have all of these areas of these triangles. The area then of the polygon would be the entire 48 units squared, and subtract 18 and 6, so 24 units squared, leaving you with 24 units squared. So on a little piece of graph paper, or draw yourself a coordinate plane, go ahead and find the area of the polygon with these vertices. And you may use either method, whichever you think would work best for this polygon. Once you've done that, come back and check your work. Okay, the key here has drawn the polygon as you see, and enclosed it in a rectangle. So this rectangle goes from negative 6 all the way to positive 6, so we have 12 by 8, 12 times 8, 96, right? So 96 units squared, and then we have 1, 2, 3, 4 triangles to subtract. So the triangles were found, and when you subtract, we end up with 48 units squared. Very good. You simply have a lesson quiz, so pause the video and come back, and then you'll be on your way. The first area, estimated area, is 25.5 units squared. The second perimeter and area are given. Perimeter is 4 plus 2 times the square root of 10. Area equals 6 units. Finding the area that you see, don't forget to pause, come back and check it out. You should have found the area of 12 units squared, and you could simply show the combination here of areas, and they both have 6 units squared. So your assignment is here. Have a good day.